For this question, we have the impedance of a capacitor decreases as the frequency increases. Is this true or false? So what we're saying here is that we have some capacitor, and our capacitor will just look like this. And the impedance, which is Z of C, is equal to 1 over Rj times omega times C. We can rewrite this as negative j over omega times c. It's the same thing. And as the frequency increases, what happens to the impedance of the capacitor? Does the impedance of the capacitor decrease? Well, if we use some common knowledge, and we can even look at the site, the impedance of a capacitors and inductors in a circuit depend on the frequency of the electric signal. So impedance of capacitors and inductors, for that matter, both depend on frequency. The impedance of an inductor is directly proportional to frequency. So that means for an inductor, when the frequency increases, the impedance will increase as well, while the impedance of the capacitor is inversely proportional. So since the impedance, and we're going to highlight this, the impedance of a capacitor is inversely proportional to our frequency. That means as frequency, we'll say F, increases, then our impedance for the capacitance decreases. So that means when we have this saying, the impedance of a capacitor decreases as frequency increases, it's going to be true. So the answer for this is true, and the source that we use is going to be linked below the like button in the description. And that's how you'd go about looking at something that tests you conceptually like this.